Hi, welcome back to class. Today we shall be looking at a very important topic, differentiation. I know many of you have heard about differentiation before now, and quite a number of persons might have told you that differentiation is a very difficult topic. I am one of the few persons who do not think that differentiation is difficult, and that's why today I am going to be showing you very quick ways you can solve differentiation questions. Remember that this is a tutorial, so we are going to be using the quickest possible method to give you the answers to seemingly difficult questions. So first, what do we do in differentiation? Like the name implies, you simply find the derivative of a function. There are several ways that we denote derivatives. The most common way is by saying the y over the x. Sometimes this is written as f prime of x. Other times you could see it as y prime. Then there is a standard form which is d over dx of a function. So when you see any of these, it connotes differentiation. So when you see find dy dx, find f prime of x, find y, find this. So let's see different ways this can come. For example, if I write y is equal to x squared, I can say find y prime. That's differentiate. Or I can say find dy dx. You see, because y has been written in terms of x. You will find out that when y is given in terms of x, in fact, when one variable is given in terms of another variable, you call those kind of functions explicit function. That is, an explicit function is a function where one variable is given in terms of another or other variables. We will not dwell on that for so long today because that's not within the scope of our work. So, if you have y given in terms of x, you could be asked to find y prime or the y dx. Now, sometimes you could be given something like this. If f of x is equal to x squared, if f of x is equal to x squared, then the question could be find f prime of x. You see that? So whether you see y prime dy dx, f prime of x, it all means differentiation. When the examiner doesn't want to use any of this, the question can easily come as evaluate d over dx of x squared. Now, this means differentiate x squared. So you see that? So whether it is this, or this, it connotes differentiation. So very quickly, how do we differentiate functions? Or how do we carry out derivatives of functions? We are going to start with simple explicit functions, because in reality, how you differentiate a function depends on the nature of the function. How a function is differentiated depends on the nature or the type of function. The first type of functions we are going to look at are what we call simple exponential functions. Simple exponential functions. These functions are generally given, as ax raised to the power of n, where a and n are constants. Take note, a and n are not variables, they are constants. So when I have a constant standing as a coefficient. I have a variable x, and then n is serving here as the power. It could just be a simple exponential function. How do I differentiate this sort of function? It's very simple. You use this principle that if y is equal to ax raised to the power of n, where a and n are constants, dy over dx will be equal to ax raised to the power of n I'll explain this so that you get it very quickly. If you've taken note of that, let me give you an explanation. If y is coefficient, variable, power, a is the coefficient, so let's come up here and see that now. Y is ax raised to the power of n. So let me label this as coefficient. Let me label this as power. X is the variable. Because this is an explicit function, y is called the dependent variable, x is the independent variable. In differentiation, we usually differentiate with respect to the independent variable. So in this case, dy over the x, which is the derivative of this function, is the power times coefficient. Power times coefficient. Power here is n, coefficient here is a, then you have your variable x, and subtract 1 from the power. So power minus 1. This is how we differentiate. So if y is equal to ax raised to the power of n, dy dx is n times a, then x raised to the power of n minus 1. That's quite simple. Power times coefficient, power minus 1. So for a very quick example, I'm sure you're getting excited about this already. If y is equal to 3x raised to the power of 4, 3 is coefficient, 4 is power. So I can simply say dy over the x is equal to 4, which is the power, times 3, then x raised to the power of 4 minus 1. 4 times 3 is 12, x, 4 minus 1 is 3. Hooray! You differentiated. Sounds exciting, right? Simple too. So, basically, when I want to differentiate a simple exponential function like this, the principle is power times coefficient, then you subtract 1 from the power. It's that simple. Now, don't get too excited yet, because there are some times when you see questions that don't just come out exactly this way. The examiners could model them up because there are different forms we can represent power. For example, some of these functions could have negative powers, some of them could have fractional powers. But there is a piece of good news. What's that good news? The process is the same. Whether the coefficient is a fraction, a negative number, or the power is a fraction or is a negative number, it doesn't matter. The principle still remains power times coefficient and subtract 1 from the power. So let's take an example of a situation where I have a negative power. For example, if the power happens to be negative, it doesn't necessarily change the process. So for example, if I have y equal to 5x raised to the power minus 2. Now, here is a negative power, but the process is the same. The process is the same. I would simply say the y over the x is, now the power is what? Minus 2. Please, the power is not 2, the power is minus 2. So the y dx is minus 2 times 5x minus 2 minus 1. The process is power times coefficient, variable, power minus 1. Minus 2 times 5 is minus 10. X minus 2 minus 1 is minus 3. Differentiated. Wow, quite easy. Please don't forget that in the rules of indices, powers may not always be shown when they are negative like this. So that this question could have been given as y equals 5 over x raised to the power of 2. So you may need to have converted it to this. I hope you do understand that. Let's take an example where we have a fractional power. Take, for example, y is equal to 2 over 3 x raised to the power of 4 over 3. Now, we have a fractional coefficient, a fractional power. It doesn't change. The most important thing is that both the coefficient and the power are constants. That's the most important thing. So you take note that both the coefficient and the power, they are what? Constants. If you have established that the coefficient is a constant term, the power is a constant term, all you need to do is to say the y, the x, is equal to power times coefficient. 4 over 3 times 2 over 3, right? X, 4 over 3 minus 1. Wow, that's the same thing. So you don't necessarily have to, bother your head about is it a fraction or not. It's just so simple. 4 times 2 is 8. 3 times 3 is 9. So this gives 8 over 9. X, 4 over 3 minus 1 is 1 over 3. 1 over 3. That differentiation is quite simple. So whether you have a fractional power, you have a negative power, the process is power times coefficient, variable, subtract 1 from the power. Then that's quite easy. You got that right? Sounds easy, right? You could try a few of them that in your textbooks to see how it goes. It's quite simple. Don't forget, differentiation is always with respect to the independent variable. So I'm going to just show you a little trick. Let me show you a little trick in situations where you have negative powers. I want to show you a little trick, something you could do, just a little trick. You could say if y is equal to a over x raised to the power of n. Now, this is a situation where I am supposed to have a negative power, but the power is positive and in the denominator. So that instead of having y equals ax raised to the power of n, we are now having y equals a over x raised to the power of n. Now, differentiating this is very simple in so much as a and n are constants. In this case, you can simply put the y, the x as minus a times n over x raised to the power. That's quite simple. Now, this is a bit simple compared to having to convert. Let me show you this so you can appreciate. For example, if I have y equal to 3 over x raised to the power of 5, I can simply say the y over the x is equal to 5 times 3 is 15. 5 times 3 is 15. So this gives minus 15 over x. 5 plus 1 is 6. 5 plus 1 is 6. That's all. See what another student could have done. Another student who is not aware of this relationship I've just shown you, he could have said y is 3x raised to the power of minus 5. Then he would say the y, the x, is minus 5 times 3. That would give him minus 15. Then x raised to the power. And then he would need to convert this back by taking this downward, which would then give him minus 15 over x raised to the power of 6. That's, of course, according to the laws of indices. But you agree with me that it is faster to just say power times numerator, then you put a minus sign in front and add 1 to the power. Let's take that again. Let's look at an example. Take that again. Look at this. This is a very common expression that we get to differentiate. When I say y is equals 1 over x, according to the rules of indices, the power of x here is 1. So rather than write 1 over x as x raised to the power of minus 1 and then going through that long process to differentiate, because I'm in an exam situation, I could simply say the y, the x, that's by going straight to the point, is the power of x is 1. 1 times the numerator, which is 1, is what? 1. 1 times 1 is 1. So we have minus 1 over 1 plus 1 is 2. X raised to the power of 2. So the derivative of 1 over x is minus 1 over x squared. Now, this is a derivative you may want to have up in your notes, and then you have it up in your head. Don't forget, you're not going to be asked about things in your notes. You're going to be asked about things in your head. So you want to transfer this from your notes to your head. That when I differentiate 1 over x, I get minus 1 over x squared. Let me give you one to try very quickly. Let's see how fast you can get. When I give you y is equals 2 over x raised to the power of 3. So I'll give you the next 5 seconds to tell me. Okay, did you get that quickly? If you didn't get that because of time, you could have said the y over the x is equal to what? Minus 6 over x raised to the power of 4. 3 times 2 is 6. That will be minus 6. 3 plus 1 is 4. Finally, the numerator could be negative. You could have a negative numerator. In that situation, I will need to just follow the protocol, taking note that the negative numerator will cancel out the negativity in the answer. Take a look at this. Y is equal to minus 5 over x raised to the power of 8. There is a minus sign, so that means the y over the x would be equals to 8 times 5 minus 5 is minus 40. So the numerator would just be 40 x raised to the power of 9. Did you notice that? The negative answer that would have been here been taken care of by that. So it gets quite easy.